Okay. Okay, so in Germany it's Industry 4, and in China we see the Made in China 2025. It's where China decided, the authority, I believe, that they will make everything, all the automation by themselves, and it will be capable of IoT. Okay, so let's speak about my first Industry 4 use case. Okay, I don't want to get into trouble with my family, so I will speak about mail. I got on the phone, hey, everybody has a cell phone in the car. I got the yellow light is on. You see, this yellow light is on. Okay, so at the same evening, I went to and I filled the air in my four tires. And believe it or not, after 2 days, I go on the phone again. Hey, the yellow is on. You didn't do anything. Okay. So in this case, I had already a trigger that if this happen again, then probably I will do something more drastic. So after 2 days, I went to the garage, and the garage lifted my cars, and he was able to find that one of the tires had an issue, and he was able to fix it. Okay, so this is typical IoT example. So we have a sensor in the wheel of the car. This is the cyber, the physical system, and if it's below a certain level, it flash a warning. It doesn't tell me to stop the car. It tells me, pay attention. You may have to add air, or you may have an issue. I don't know. Okay, so in this case, instead of have a flat tire in the middle of nowhere, like in North Wisconsin, I was able to fix the problem in advance and avoid a shutdown. Okay, now we have a question here, question mark. And the next question is, if you look at my dashboard, this is my dashboard, my car dashboard. If I drive into a gasoline station, on which side is my gasoline? Is it on my left side or on my right side? I don't know if you want to write on the chat. You can write. I don't know. Some of you, do you like to try to write? Is my gasoline is on my left side of the car or on my right side of the car?
Left.
You can write on the chat. You see the chat, just write right or left. And I will tell you. Nobody write. Did anyone write on the chat? Can you try to write on the chat right or left? No, on my car, not on your car. Somebody write me what is on his car. Okay. Okay, so in this case, you see this small arrow? This small arrow tell you where is you have to fill your gasoline. And it's tell you on the left side. So when you drive into a gasoline, make sure that the pump station is on your left. Now this sign is for many years on many cars. When I asked this question in China, first they were afraid to answer, even the one that know the answer. In Germany, believe it or not, but everybody know it. So I don't know if they teach it in high school. In USA, I get also like 80% know the answers. And in Israel, there were like 50% that know the answer. In this case, what I want to express is that there is an information of Industry 4, but you have to teach the culture that there is an information and to look at that and what to do, because many people see it in the car and there is a lot of information and they don't know what to do. Many people also don't know what the orange icon say. So in Industry 4, and I will speak about it later, We have tons of information, but people doesn't know how to collect it and what to do with the information. Okay, and now we go to my industry 2 use case. Okay, let's say in the old day when they made the T model car, I believe that everybody from USA know what is the T model. In China, most of the people didn't know what is T model, and in Israel, like 20 to 40% know what is the T model car. This was the first car, mass production was developed by Henry Ford. You can ask for red car, for blue car, green car. You will get a black Ford. That's the T model. So Model T was an automobile built by Ford in the year of 1900, and it sold like 15 million cars. It was praised for its low cost, durability, versatility, and the ease of maintenance. So this is the car Model T. You can see here in the picture. And the big question, I ask you why it's my use case. So this gentleman here is my grandfather. And this is the car of my grandfather. So when I speak in terminology, my grandfather is industry 2, I am industry 3, and the young people today in the company might be industry 4. And this little boy, it's probably my father. This picture was taken in Borneo, Indonesia in 1992. So the only things I want you to take from here, you know now what is industry 2. Industry 2, it's my grandfather H. I am industry 3, and I believe all the young generation today, 20 to 30 years, will start using industry 4. Okay, so what is industry 4? This is a rough example. I have many robots, so I can call robot STX 255 and ask him how you doing, and he can tell me, oh, I'm good, all my parameters inside the tolerance. I can say you should take no more than 1 kilowatt an hour, your temperature should be below 40, and I can measure the energy in 24 hours. So if the energy is inside the tolerance, then the robot is 32, then it should be okay. Okay, so this is example. I'm looking, I can check many robots and using any application to check the status. Okay, so here you can say another slide for the evaluation of the industry 1, 2, 3, and 4. So this is England. This is Detroit. This is today, the robots we are seeing today. And industry 4 is you can connect and speak with all your device in the machine. Okay, so if you remember in 2006, there was no iPhone, no iPad, no Kindle, no Android, no WhatsApp, no WeChat. We didn't have all this application. Now, if we speak about motion, most common servo applications back in 2006 were analog command to servo drive, and in return we had a feedback encoder of A quad B. There was no data exchange like temperature. I couldn't know the temperature of the servo drive. I couldn't pull up the temperature of the motor. Now, field bus was started like the can open, was introduced by Bosch. This is the most common. You have it in your car today. In 1994, EtherCAD, which is very known today, was started in 2003 only, and it took them like 4 to 6 years to get real high axis numbers. And we have, of course, the Profinet and Ethernet IP, which is the most dominant. But to know what's happening in the device, you must have a field bus to take the temperature information or any other information upper to the control of the whole factory. Okay, so this is just how long to reach 100 million users. So many years ago, it took, just for the telephone, it took 75 years, 7 years for the web. And then Pokemon, that was years ago, it took 1 month to get to 100 million users. Okay, so let's speak about IoT and IIoT. So the idea of IoT is to collect big data, to do the analytic of that and take decision. So you have like a switcher, server, computer, you have a factory, you collect all the data, you can do commercial, you can do temperature, all this data, and then take a decision based on this information. Okay, so here I just have a basic example, which I will go through the presentation, because big data we can speak for many years. So we have 2 servo drives. In this case, we have the CDHD. So I'm going to measure the temperature of the power stage in Celsius. So that means I will monitor. And the power is the current, it's the torque multiplied by the speed. And the torque, if you are familiar with motion, is the MKT of the motor multiplied by the current of the servo drive. So I can get the power in watt, and I can get the power in Celsius. Since I have a field bus, this information will go to the motion controller. In this case, it's a soft MC. It can be any soft MC. So this is sensing. This is the hardware. Then I have the OPC UA, where I communicate over Ethernet IP. So I collect all the data. Then I have to do analyze of this, and then I have to decide what to do. If you remember the case of the car with the orange light, I have the orange light, and I wrote here, and my first analyze was to fill the tires. But I keep aggregating data. And when I got the same issue within 2 days, then I decide to go to the garage. Now here we have a use case, a real one, from one of the fab here in Israel. Fab is where they're making the silicon. So the factory aggregate the energy consumption of each station. So one station show an energy increase. So what they did during the weekend, okay, on Friday, not on Saturday, in Israel they don't work on Saturday, they look at the specific machine, and they found there was an issue with the vacuum. So the station worked properly, but there was a small hole. So once they fix the vacuum, they prevent a shutdown of this cell, which can cost them a lot of money. So IoT, you will see where it's save money. Like if a shutdown costs you a lot of money, company will start invest in IoT. And this is a typical use case of a fab factory. Okay, now general speaking, we generate tons of data, but we still don't know what to do with the data. And I think Industry 4 was introduced, I saw it on the SPS maybe 4 years already or 5 years already. And the issue is, oh, I hear it from somebody, just a second. Okay, now I go back here. The issue is we generate ton of data, but we still don't have what to do with the data and how to control it. Okay, so if you look, you have the machine or the robot and sensor and actors and machine. These are the things, okay? I measure the temperature of a robot. Then we have the TSN, or the OPC UA, and we collect all this information. We can go all the way up to the cloud. And there are all kind of, you have Microsoft Azure. Microsoft Azure, for example, you can buy you can have for free like 12 tags or 20 tags. And if you go to the SPS, you can see some demonstration that they pull information from the machine to the cloud and what they are doing with this. So IoT is the industrial of things. Okay, and here you can see more details, examples. So we have several cells. This is a machine, this is a robot, this is a Delta robot, a Puma robot. So each one has servo drives or electronics. And all of them, in this case, speak with EtherCAD, with a motion controller. In our case, it's a SoftMC. The SoftMC speak with OPC UA with IoT software that can do data, remote access, they can collect the information and do many, many other things. Okay, and in the example I'm going to show you, this is the structure that we show the way we are doing. So we have the SoftMC, which is an OPC UA server. We have an HMI. In this case, we use the one from Schneider. And we build all the robots. So this is the bridge. And from here, you can go to anywhere you like, to the cell phone, to the cloud, or wherever you want. So on the left side is the robot or the sensor, motion controller, Ethernet IP going to the HMI, and then you can use the AMQP cloud gateway. Okay, the OPC UA has three key highlights. It's an open data connectivity, it's a data context, and how also very, very important in industrial today is also several levels of data security. I will go very short about the OPC UA. If you want to know more about OPC UA, you can go to the website of the organization. There are tons of information about OPC UA. You can use any operation system. I don't know if you're familiar. Before the OPC UA, there was OPC DA. OPC UA know to work with Microsoft, and in our case, it's now to work with Linux. Because the SoftMC, for example, is using the Linux operation system, and it can work on any hardware platform on Intel or ARM. So in our case, when we use ARM and Linux, we could use the OPC UA. I'm just watching the clock. We are still good in the time. So we have the client, which will be the HMI, and I have many OPC UA servers that will talk with the OPC UA. And data security, I don't go, you can have encryption and any one of the encryption that you want to use. You have to define it on the server and on the client. Okay, to be more practice, here is something that we show in Germany, SPS show in Nuremberg in November. So here you can see 3 robots with a screen. And here you can see like things you are sitting in the control office, and you can see every one of the robot. So for example, you can see the green, it means that the robot is operating. So all this information from the robot go via, in our case, EtherCAD to the motion controller, and then we use Ethernet IP and the protocol OPC UA to speak with the HMI screen. So you have the simplicity of GE, you have factory torque of Rockwell Automation, and you have the one machine of Schneider. Okay, how we implement it? Okay, the way we implement it, we have the motion controller. So we have, in our case, the MC Basic, and we bought a software development kit. The software development kit is the one where we put the OPC UA. So every global variables that we have here, we can open in the client and see the value of the global variable. So I call it sometimes a higher level of Modbus TCP/IP. In Modbus TCP/IP, the one that knows how it works, you have to define the 40,000 something for every variable, and then on the other side, and you have to do lookup table, and it's not so convenient, but it works perfect, and many applications still use it. In OPC UA, instead of defining a number, all the global variables are available on the client. Okay, so in our case, what we are doing, this is in the motion controller. I will not go into details, but I will try to show it. So we have a program. So in this case, we read the temperature of servo drive number 1. So we use EtherCAD, and this is the exact object for the temperature. So we get the temperature and the power. We actually, what we do, we measure the torque feedback, and we multiply it by velocity divided by constant to get the units for watt. So in this case, we are reading the temperature via SDO, and we read also the power via SDO from the servo drive to the motion controller. Okay, so if you decided to do also an application with OPC UA, you might want to use the UA Expert. It's a free client debug application that you can download from the website. So if I open the UA Expert, I have to connect to the motion controller. And once I connect to the motion controller, I see all the global variables. And I can manually set value or read value of every global variable of the motion controller. So in this case, I have the servo on or servo off, and I can change it via the Ethernet IP. I can read the position feedback or the temperature of the specific servo drive. Okay, so now I go from, we have the servo drive, we have the motion controller, and now I have the HMI. HMI, it's the screen I'm building to be at the control office of the factory. So the first things I have to do, I have to connect to the motion controller. So I have to connect to the soft MC, is a server. This is the TCP/IP of the motion controller. Once I get that, the next things I have to do is to attach the motion controller variables to HMI tag. So let's go to just one of them. So in this case, I have the enable, and I build a tag that's called Puma enable 1. So I can build tag, and I'm not going to explain what is tag in HMI. Just in 2 words, this is the object in the HMI that I can make animation and many other activities. And for that, I use the Wonderware of Indosoft. Okay, so let's be more practice. So I have Puma enable. So I use this light, and I tell him, you are green when Puma enable is 1, you are red when Puma arrow, and you do it blinking, and you are yellow when Puma enable is has a blinking. So that's the way I define how the light will work. The other place I build is this column. So it's from 0. You see 0, that's the minimum. And I know already that the servo drive usually operate from 0 degree to 100 degrees. And this is correct for all the industrial servo drives. So here I build a tag. This is a tag, object properties. And I connect the Puma power temperature from 0 to 100. And I set 60, that's the warning level. Usually I can work with the servo drive in 60 degrees, but hey, pay attention, something is wrong there. Go and look at that. When it reaches 80 degrees, then you have a problem and the robot might stop or the axis will stop. Okay, so here is my Industry 4 control room. Okay, so in this case, this is what we use in the SPS show. So we have, on the left, we have 3 Delta robot. So I have the traffic light, green, it's enabled, blinking yellow, maybe it's off, sorry, you can see here, and red is arrow. So that's the first thing. So I'm sitting, I see, I'm expecting to see green of all the 3 robots. Then I have the temperature. Each robot here has, in this case, 5 axes and one more for auxiliary. So I want to see that all of them in normal work will show something like 40 degrees. Okay, and here I have the same. That's the 3 robot with a screen. And by the way, in the SPS we had an issue, I remember, that one of the axes of the robot almost reached 80 degrees. And I told to the application engineer, hey, look, you have a problem. And what's happened, after 5 minutes, the robot stopped working. And we learned that the servo drive was closed in a cabinet. And the way to fix the problem was to open the door. Once we opened the door, we didn't have this issue anymore in the show. Here I measure the energy and the number of cycles. Okay, here is another example of control room. In this case, I measure the temperature. I can look at the velocity and the power of each one of the robot that I show in the show. Okay, one more regarding the OPC UA. There is the VDMA. It's the German community for automation. Because I'm an OPC UA member, I was allowed to be and hear about them. They are working, and they already started a year ago or 2 years ago to have a protocol for robotic for OPC UA. So it doesn't matter if the robot is from KUKA or from Yaskawa or whatever. I don't know exactly all the brand name, but I know all the big brands robotics are part of this initiative. So you can see here different robots, and all of them send information in the same format to one place. So this, let's call the cloud one place, know the status and the condition of each robot. Doesn't matter the brand name and the type of the robot. And if you like to know more, you have to contact this guy. Every several months they're hosting a seminar, and they already, I think, accomplished several specifications for the robotics OPC UA. I looked in Israel. In Israel, we have only 6 companies that are OPC member. In Germany, there are 200, and USA also 200 in China. But all the big brands like Siemens, GE, supporting the OPC UA. To have Industry 4, you must be able to collect a lot of information like temperature and power and take them all the way to the control room of the factory. Okay, so now I'm getting to the summary, and then I will have several minutes if anybody wants to have any questions, so please use the chat to have a question. So what we are doing, we are collecting tons of variables. It can help us in maintenance, prediction, so we can avoid shutdown. You can compare finance to similar manufacturing. You have tons of information. You can do a smart factory. What is a smart factory? Today you want to have a car with a yellow wheel, orange color, and the seat will be blue. If you remember the Model T car, it was on one line. Today, the car industry, the car go on a AGV. It's a guided vehicle, so it can also take the right. So you can set all the things you want from the cars, and you will get it. For example, today you have a battle with RFID. So on the RFID, it will say if you want limonada, orange, or I don't know what. So he tell to the station to fill it with orange or limonada, and then which label to put on it. Okay, now the common rate, when you speak about communication, there are 2 major parameters before you start any communication. The first one is it deterministic, yes or no, and what is the update rate. Okay, because when we do motion, in some cases we go to 1 millisecond, or robotics we can do from 1 millisecond to 4 or 6 milliseconds. IoT or OPC UA, you can do, let's say, general speaking, 100 milliseconds. So every tag you see on the HMI, it will be updated every 100 milliseconds. Where do you see IoT or where you see motion with OPC UA? So mainly you will see it only on a large scale process and manufacturing. What I saw, it's hard to see in real industry with IoT. Everybody speak about it, but you don't see it as common as people speak about it, because if I have a factory and it's doing the job, nobody want to touch it. So only new installation or new large scales, you will see the IoT. So always when you decide on IoT, it's always good engineering versus practice engineering and the cost associated for that. So bottom line is, if your motion system has a field bus like Profinet or EtherCAD or CanOpen, you can collect information from the H devices, and then your motion controller can send it up to the cloud or to the HMI. And then the case is where do you want, and then you have to also to find a diagnostic what to do with all the information. Remember all the time about the example of the orange icon of the tire. OPC organization, so you have the president, I believe it's still Stefan Hoppe. They are sitting in USA, but as far as I remember, I don't know him personally, but Stefan Hoppe came from Beckhoff, and Beckhoff liked to lead the communication in the industry, so probably that was one of the reasons. And you can get there all the information about OPC UA, and it's become more and more popular, the protocol that running on Ethernet IP from the usually motion controller or the server drive up to the cloud or to the HMI. Okay, now I have several questions. I will put them here and I will try to answer. Somebody asked if we are independent from Servotronics or it's a sales arm across the world. We are independent from Servotronics. We are the only one to sell Servotronics outside of China. It's not a sell arm. We are a company. We also sell Servotronics, but we also sell motors, gears, and we give also full solution for motion, and we also doing some development. Okay, so I see this is all the question. We are almost at the end of the week, so tomorrow in Israel it's a holiday. I don't know how to say in English Shavuot, but this is one of the 3 pilgrims to Jerusalem. So I will end up here and wish you. No, no, I'm not in Canada. I'm not in North America. I'm in the Middle East. I'm speaking from Tel Aviv. We have great weather here. STXI Motion, the headquarters is in Tel Aviv. We have a facility in Europe. We have a facility in USA, and we have a facility in Korea. Support structure is if you are from Canada or North America, you can contact our people in USA. Mainly they are located in Chicago. If you are in Europe, then you can contact our team in Germany. And if you are Korea, you can contact our team in Korea. Yeah, I'm going to have a very nice holiday. And I wish you all nice weekend, and we'll meet on one of the other webinars. Thank you very much. Bye.